So we're going to talk about direction angles very quickly, but go ahead and pause real quick, write this down. You also need a calculator for this, so you may want to pause and get a calculator. So this direction angle formula, or the definition, says if u is a unit vector, then theta is an angle from the positive x-axis to your unit vector, to u. The terminal point of u lies on the unit circle. So if it's a unit vector, the terminal point will be on the unit circle, which would make sense because the unit vector's length is 1. And we know the radius of a unit circle is also 1. But you don't have to have a unit vector to find the direction angle. The part that's important here is that if theta is an angle from, let me move that, from the positive x-axis to u. Okay, so what does that mean? Just to give you kind of an image. So let's say we have a vector, and remember our vectors always start at 0 and they go out to that terminal point. So here's my terminal point, and here's my vector. Then from the positive x-axis to that terminal line would be my angle. This is called the direction angle, and the direction angle is from your positive x-axis always to wherever your vector is. So your vector can be up here, it could be down here, it could be anywhere really. But normally we go in that counterclockwise direction. Now I just want to point out a couple of things that we need to kind of point out. If this is vector u, remember that that means that this is u1 comma u2, that point. And then note that this could create kind of a right triangle if we go across and up, where this is the x length of the triangle and this is the y length of the triangle. That's the u1 and the u2. So we would say that x is u1 and y is u2. And that's from that coordinate there. But also remember that from trig, x represents cosine on a unit circle and y represents sine on a unit circle. Okay, because there's a formula that you need for this, and it's all going to kind of come into play right here. It's the tangent formula. So to find the direction angle, we use the tangent of theta is equal to our opposite side over our adjacent side, or sine over cosine. That's our formula from our last unit, sine over cosine. Or we can say that the sine is y and the cosine is x. Or if we're talking now in our case, it would be v2 for our vector over v1. Okay, that's the y component of the vector over the x component of the vector. So this is like all the same formula you should recognize from all the different units that we've done, but we're utilizing it in a vector notation. So it's to find this angle here, you choose the opposite side over the adjacent side because those are the sides that you have. You have those coordinates. Now we do kind of simplify this a little bit. Sometimes you will see tangent theta, and you might see it in my math lab, is b over a. A would just be the y component, or A would be the x component and B would be the y component. So that might be the formula that you see a lot of, but it's the same thing as everything up above here. Another formula that you need to know, okay, is to find the vector. So to find the vector and to put it in component form, if you have the direction angle, so this is to write the vector in component form, if you have the direction angle, would be to take your magnitude of your vector, so the length of your vector, because remember, this direction angle is usually only when you have a unit vector, so the unit vector has no length other than 1. So you'd have to have magnitude, and then you would have to have a vector. Well, we only have the direction, which is the angle, so it would be cosine of theta for the x component and sine of theta for the y component. And remember, cosine is x, sine is y, and that you would multiply it by your magnitude. So that's a way to write the vector if given the direction angle and the magnitude. Now, in this case, theta represents that direction angle. Okay, so let's go into an example really, really quickly. The example will be below in a second. Okay, so I decided to use I's and J's just to kind of have another example with I's and J's. This is a linear combination. You can go back to component form versus linear combination video, and that will talk more about how to convert from one to the other. So remember, it can be written as a linear combination, or if I want it back in component form, I would just take the numbers in front, 3, 3. Remember, I is the x component and j is the y component. So let's say we want to find our direction angle. So to find the direction angle, as kind of like a little bit of an example, just to give you kind of an image of what's happening here, I would always suggest to graph your vectors with direction angles because it makes it a little bit easier to figure out. But we have a vector going out to 3 up 3, and that would be right here. And then the line goes from the 0 to that vector, to that terminal point. Now, the angle that we are trying to find is this one here. Okay, that is from the positive x-axis to our terminal side. And the formula that we are going to use is tangent of theta is equal to that b over a or y over x or v2 over v1. It doesn't really matter which one you use. I'll use y over x here because we all know x and y. And then we can plug in what we know. So we have 3 for y and 3 for the x component. So this simplifies to tangent of theta is equal to 1. Now, as a reminder, to find your angle, we have to take the inverse of the other side. So we're going to say tangent theta, or tangent of inverse of 1, and then we can actually utilize the calculator. So we're not going to be using like unit circle, we're not going to be using anything like that. We're going to make this as easy as possible and utilize our calculator. Now, make sure your calculator is in degree mode. Mine is in degree mode here, but if you don't know, you would put the DRG button, click that, and make sure degree is underlined, and hit enter. So now I'm going to do second tangent because I want that inverse. So second tangent and then put in 1, close parentheses. And my answer is 45. So because it's in degree mode, my answer here is 45 degrees. If you're looking at your vector and you're looking at where your vector is located, and if it's in quadrant 1 and you get an answer in quadrant 1, then you know that you've done this correctly. Okay, we're going to go on to example number 2. So here's our vector, 3, -4. And I've already gone ahead and drawn it for us. So this is where the vector is located. We are in quadrant 4. Remember that the direction angle should start from the positive x-axis, go all the way around, and end at that line there. So this should be theta. Okay. So we need to kind of see what we get when we use our formula for tangent of theta is equal to y over x. u2 over u1, whatever, from this coordinate there. So I'm going to plug in -4 over 3. And then we're going to, remember, do our tangent inverse. So the formula is actually really super easy to find direction angle. The problem that you're going to run into is what we're going to face just now, is when we enter this negative and see what happens. So I have tangent inverse of -4 over 3. Clear my calculator. Second tangent, make sure I'm in degree mode. -4 divided by 3, close your parentheses. Make sure you use the negative button and not the minus sign. If you use the minus sign, then you're going to be in trouble. The negative button is down here. Hit enter. Notice that I get a negative value, which is not what I want. I want something that's in between 270 degrees and 360 degrees because that's quadrant 4. So the problem that we have here is that the value that you are given for this, entering it into the calculator, actually gives you its coterminal angle here. And you actually have to do some calculating to get back to your angle. And in this case, we actually use coterminal rules, and that's from our last couple of units ago. So remember, the coterminal states that we take and add 360 to our angle, and that will give us our final answer. And our final answer in this case should be 306.87 degrees. I do have 2 more examples because I want to show you what happens in quadrants 2 and in quadrant 3. So I know this is a little longer, but stick around for quadrant 2 and quadrant 3 examples. Okay, so I went ahead and did both and put both examples up there. So we have one in quadrant 2, and I went ahead and drew both of them. But we have a vector in quadrant 2 and a vector in quadrant 3. So we're going to see what happens with this formula with both of them. So remember, the angle that we want starts from the positive x-axis, goes out to that terminal side. So this is the correct angle that we want, positive x-axis to that terminal side. So let's go ahead and take tangent of theta and place our value y divided by x. So that's going to be 5 divided by -2, or b divided by a, whatever you want to say. So we're going to divide them, and then we're going to do our inverse tangent, and we're going to plug this into the calculator of -5/2. Now, when you do this, I'm going to let you do this because we've done the calculator a couple of times. You should get -68.2. Now, -68.2 once again gives us an angle in the fourth quadrant here. It gives us this angle right here, -68.2. And the problem is that I don't want an angle that's all the way in quadrant 4. I want an angle that's in quadrant 2. So how do I get from quadrant 4 to quadrant 2? Instead of adding 360 degrees, hopefully you said add 180 degrees to this. So once I add 180 degrees, then I should have the correct angle in the correct quadrant. So you're going to want this angle instead. Okay, looking at this last one, if you want to pause it and try it first before I get to it, absolutely go ahead, but I'm going to just dive right in. I have tangent of theta is equal to -1/1, or -1, sorry, and then I have theta is equal to tangent of 1. We've actually done this once before. Tangent of 1 is 45 degrees. Now the problem here is that this gives me, so I want an angle that goes all the way around to my terminal side, and what I got instead is an angle in quadrant 1. So I got 45 degrees. So once again, I want to go from 45 degrees all the way across to quadrant 3, and that is again when you are going to add 180 degrees. So each quadrant has its own set of rules, and that's why I wanted to go over all of them so that you knew the rules, and hopefully you did stick it out till the very end, because that way you know the rules for each quadrant, okay? But that is technically what you have to summarize and recap really, really quickly. In quadrant for direction angle, we're always using the formula tangent of theta is equal to y divided by x, or b divided by a, or v2 divided by v1, whatever you want to call it. And then in quadrant 1, remember there was no change. So the answer that you got from that formula is the answer that you keep. But quadrant 2 and quadrant 3 because of what happens with the formula and not the formula, but really the equation here, and when you take tangent inverse, you're going to have to take your answer and add 180 degrees. Okay, and that's going to be in quadrants 2 and in quadrants 3. And then in the final quadrant, quadrant 4, that's when we find that coterminal angle, and we take theta and add 360 degrees. So that's going to be when you find your final angle there in quadrant 4. So one of them is no change, the other two are add 180, and then the last one would be to add 360 degrees. Okay, that's all I have for you guys today.